Can you imagine, as a market analyst working for a large supermarket, and every day hundreds of customers walk into the store, pick different products, and head to the checkout counter? You realize that the first customer buys milk, bread, and cereal. Another customer buys milk, bread, sugar, and eggs. And then the third customer leaves with milk, bread, and butter. At first glance, this shopping basket may seem random, but are they really random? As a market analyst, one question keeps coming to mind. Which items are frequently purchased together by customers? In answering this question, we can learn a lot about customer buying behavior. And this challenge of discovering relationships among items purchased by these customers is known as the market basket analysis. But with thousands of customers and millions of transactions, how can we uncover these hidden patterns efficiently? To solve this problem, we turn to a powerful data mining technique known as association rule mining. This technique is used to uncover relationships within transaction data, and these relationships are expressed in form of rules. So, for example, a rule such as bread implies butter suggests that customers who purchase bread often purchase butter as well. Likewise, a rule such as sugar and bread imply butter indicates that these items frequently occur together in shopping baskets. However, it is important to note that one product does not cause the purchase of another. The products simply tend to appear together. But the challenge is determining how to discover these rules efficiently from large transaction data sets. And so, one of the most widely used algorithms for solving this challenge is the a priori algorithm. This is one of the most popular algorithms for identifying groups of items that frequently occur together in a dataset. Its main idea is surprisingly simple. If a combination of items appears frequently, then the smaller combinations contained within it must also appear frequently. So, for example, suppose the combination bread, butter, and milk appears frequently in customer transactions. Then combinations such as bread, butter, bread, milk, and butter, milk must also appear frequently. A priori uses this observation to eliminate unlikely item combinations early, allowing it to search for patterns efficiently. Let's see how this process works by solving a simple example. In this example, we have 9 transactions, each containing a list of items purchased by a customer. We're also given 2 important parameters, a minimum support count of 2 and a minimum confidence threshold of 70%. Our objective is to identify frequent item sets and then generate association rules that satisfy these thresholds. As with every a priori problem, we begin by finding the frequent one item sets. The first step is to count how many times each item appears in the transaction database. So bread appears 6 times, butter appears 7 times, cereal appears 2 times, sugar also appears 2 times, while milk appears 6 times. Since every item has a support count greater than or equal to the minimum support count of 2, all 5 items are considered frequent. These frequent one item sets form our first level, denoted as L subscript 1. The next step is to count how many times 2 items appear together. Note, a priori combines frequent one item sets to generate candidate 2 item sets. So we then scan the transaction database again and count the occurrence of each pair. Any pair whose support count is at least 2 is retained as a frequent 2 item set. So as a result, we generate a new table with the remaining pairs discarded. Using the frequent 2 item sets, a priori generates candidate 3 item sets. So after scanning through the transaction database to count the occurrences, Only two combinations satisfy the minimum support requirements, and they are bread, butter, cereal, and bread, butter, milk. These become the frequent three-item set. We can attempt to generate four-item sets. However, no four-item set in the transaction database satisfies the minimum support count. Therefore, the algorithm stops here. At this point, we have successfully identified all frequent item sets in the dataset, which brings us to the last step of generating and evaluating our association rules. Having identified bread, butter, cereal as a frequent item set, we can now generate association rules from it. To generate a rule, we divide the item set into two parts. The first part is called the antecedent, which appears on the left-hand side of the rule. The second part is called the consequent, which appears on the right-hand side. We then consider every possible way of splitting the frequent item set. So, for example, if we choose bread as the antecedent, the remaining items, butter and cereal, become the consequent, giving us the rule bread implies butter and cereal. Similarly, if we choose butter as the antecedent, we obtain butter implies bread and cereal. And if we choose cereal as the antecedent, we obtain cereal implies bread and butter. We can also use combinations of two items as the antecedent. This gives us the rules bread and butter implies cereal, bread and cereal imply butter, butter and cereal imply bread. Notice that every rule is derived from the same frequent item set, bread, butter, cereal. At this stage, all generated rules are considered candidate rules. The next step is to determine which of these rules are strong enough to be accepted by calculating their confidence. Before we begin the calculations, let's determine the value of the numerator. Recall that all six rules were generated from the frequent item set bread, butter, cereal. So looking at the transaction database, this item set appears in only two transactions, that's the T100 and T800. Therefore, since every rule originates from this same item set, the numerator will be 2 for all confidence calculations. So for the first rule, the antecedent is bread, and bread appears in 6 transactions. Therefore, the support for bread is 6. And applying the confidence formula, we obtain 33.33%. We go ahead and calculate the rest of the confidence measure, and 3 of the association rules meet the confidence threshold of 70%, which gives us the confidence that every transaction containing those antecedents will surely contain the implied consequence. In summary, market basket analysis is the process of discovering products that are frequently purchased together by customers. Association rule mining is the data mining technique that identifies patterns and associations within transaction data. And one of the most widely used algorithms for association rule mining is the Apriori algorithm.